Hi everyone, and welcome to our word problem on higher order derivatives. So we will have to find first order and second order, and then we'll make sure what we know what these mean. Okay, so in this example, it says Winston's Treats discovers that the number of biscuits sold T days after launching a new flavor is given by n of t equals 2t cubed minus 20t squared plus 100t. Find these first order derivatives and second order derivatives, and then we'll interpret the results. All right, so let's get those first order and second order derivatives. So first thing, notice I am just going to rewrite it again so I can show my power rule. Okay, so my power rule tells me how I can get n prime of t. So the 3 would multiply the front, and that would give us 6t, and then minus 1 from the power, so 6t squared. Then the 2 would multiply the front to give us minus 42. And then the last term is linear, so that would be plus 100. Okay, so there's n prime of t. And then let's do it in green. Let's get our n double prime. I'm going to do that over here. So here's still our regular. So again, just so I can show the arrows. Okay, so that's n prime of t, and so n double prime of t, the second order derivative, would be 2 multiplies the front to give 12, and then minus 1 from the power, so just t. And then the second term is linear, so that means minus 40. The last term is a constant, so that means it goes away, it's gone. All right, and now let's see what these represent. All right, so we've got n prime of 1. So we would just sub that in, so 6 times 1 squared minus 40 times 1 plus 100. And then let's simplify. So n prime of 1 equals, this would be 6 minus 40 plus 100. And then we'll just simplify it the best we can. It looks like it would be, so n prime of 1 is 66. Okay, so we've got 106. Yeah, so we got 66 here for our answer for n prime of 1. So double check with the calculator just in case, but that is good. All right, so what this means is, let's go back. Let's even put something, let's put this in red. Okay, so to the side, so just n of t. So it says that the number of biscuits sold t days is based on this. So this is total number of biscuits sold. And so for instance, if we had let's go and do n of 1 just to say what this is. So 2 times 1 cubed minus 20 times 1 plus 100 times 1. This would mean we've got, so 1 cube's not too bad. So that would be 2 minus 20 plus 100, and we'll get 82. So we get 82 biscuits sold, we'll say on day 1. So that's that meaning there. Okay, so back to this n prime. So that's a rate of change. So this is telling us that's let's write it like this. So the number of biscuits sold, is increasing at 66 biscuits per day. Okay, so that's what that represents. Okay, and that's what all these other n primes will represent. So for instance, let's just take care of all the n prime ones right now. So we've got n prime of 3. And so we're still just using our equation. Okay, so I'm back to this. So I'm just starring it. So I'm using that over again. So we'd have 6 times 3 squared minus 40 times 3, and then plus 100. and we'll simplify. So n prime of 3 is equal to, okay, so this is 54 minus 120 plus 100, and it simplifies to be 34. So n prime of 3 is 34. Okay, so the difference between our number here versus our first number, let's add one other thing I forgot to mention. Okay, so back to my arrow that I put to interpret that. So the number of biscuits sold is increasing at 66 biscuits per day on day 1. On day 1. This is still meaning very similar. It's just the number of biscuits sold is increasing at 34 biscuits per day on day 3. Okay, so it's, I don't know what this store is like, but it seems like, so there's more hype that first day because the increase is higher than the third day. Okay, so 34 biscuits per day is less than 66 biscuits per day. Okay, so it's not selling as much as it was. Okay, so but that's still okay. Okay, it's still increasing at least. All right, then let's get the n prime of 7 down here. Oh, low on room. Okay, so but we can squeeze it in. Okay, so n prime of 7. N prime of 7, still we're just using our starred formula back at the top there. So 6 times 7 squared. So 6 times 7 squared minus 40 times 7 plus 100. And then we'll simplify this. Okay, so this is where a calculator can help. Okay, so 6 times 7 squared is 49. Let's do that at least. And then minus, this would be 7, 14, 21, 28, 280 plus 100. And I'm low on room, so I'm going to put that here. Okay, so here's where a calculator would help. I don't think I can put it on the screen, so I'm just going to type it in on my calculator that I have right here with me, and it is 114. Okay, so back to a positive number. So that means this 114 is still an increasing rate. Let's just say, so because I'm low on room, 114 biscuits. Oops, let's spell biscuits right. Biscuits per day on day 7. Okay, so again, I don't really know what's going on with the store. It's a fake store anyway, but it's like the hype's back, so maybe word of mouth got around and they're saying, oh, these biscuits are awesome. You got to go try them. Okay, so it's increasing a lot more on day 7 than it was day 1 or day 3. Okay, so that's what the first derivative stands for. All right, now let's see what the second derivative means. Okay, and these are the interpreted answers. Let's just box that. And box that. And the other one I didn't write as much, but that's still good. Okay, so there's our final answers for those first 3 derivatives that are evaluated. All right, so again, the derivative represents a rate of change. Now let's see what this one means. Okay, so this is gonna be weirder. All right, so let me stick to green. Okay, so we've got our n double prime. Okay, let me star that. So we're gonna use this again multiple times. All right, so we've got n double prime of 1 would be 12 times 1 and then minus 40. Okay, so as we simplify this, well, we don't need too much. 12 minus 40 is negative 28. All right, so what this means, so well, we're gonna have to write it multiple times, but here's one way. So again, this is a rate of change of a rate of change. So what this means is the number of biscuits sold per day is decreasing at 28 biscuits per day. Okay, so see we've got per day twice. So it's like the two rates of change. So it's like a per day per day. Okay, this negative 28. Okay, so it is decreasing. What this means, okay, so let's box that up. So that's one way to consider it. Okay, so but I think the better interpretation, maybe without even thinking of the actual number of biscuits, is just looking at this negative and just saying it looks like the rate of change is going to get smaller. Okay, so this is saying your rate of change. So this is saying your n prime of t is decreasing, which shows from n1 to n3. Okay, so this is like a predictor of what's happening or what will happen for us very soon. Okay, so notice it went from 66 to 34. Okay, so it's telling us, oh, something's about to happen with n prime of t. Okay, so but this interpretation, so that this wording's strange, right? I think just thinking about it with comparison to n prime is probably a little better. But let's see the others. Let's see what happens when we plug in. So n double prime of 3. Okay, so still back to my start equation that I'm currently starting more. And then we're just changing the t into 3. And then we've got, well, this simplifies nicely. 36 minus 40 would be negative 4. Okay, so again, it's showing that there's a decrease. Let's write it like this. So this is another way to show this. So this is, do I want to do negative? Let's say decreasing by, let's say decreasing at a rate of 4 biscuits per day per day. Okay, again, the per. Okay, because it's a second derivative, so it's the rate of change of a rate, so another per. Okay, so again, it sounds weird, but what it's doing, kind of like the first one, so I'm gonna box this. This is a way to interpret it. However, again, this comparing this number negative 4 to negative 28, well, negative 4 is not as negative as negative 28. Again, it's trying to help with a predictor. And so we can see, yeah, from the first day to the second, or the first day to the third day, there was fewer biscuits sold per day. But this negative 4 is again trying to predict. Now, I don't think it would predict it that much, but it's just trying to say that the change in sales of these biscuits is looking better now than it was back then. Okay, so that negative 4, okay, so decreasing, but the rate, that 4, isn't as bad as 28 for a decrease. All right, so one more. N double prime of 7, still using our start equation. So 12 times 7 minus 40. And then this one also not too bad. We've got 84 minus 40 is 44. Now we see it's a positive. Okay, so now it's a positive. Now that's where, oh yeah, that giant 114 was what was coming in. So it looks like as more time progresses, okay, so let's still write it like this real quick. Increasing, oop, ah. So increasing at a rate of 44 biscuits per day per day. Okay, so again, it's kind of strange the way that I'm writing it here, but still what it's kind of doing again is mostly just saying, okay, so this number is a positive. It's looking like as time progresses, sales are increasing rapidly. Okay, so that's the, so it's nicer to see like all of these numbers, not just a single one. Okay, so the negative 28 is saying, oh yeah, slow start. Negative 4 is saying, okay, getting a little better. Positive 44 is saying, oh yeah, that's great. All right, now we know the cells are going to be much better down the road. Okay, so that's what the second derivative is trying to help with in application style problems. So it's just letting you know how your rate of change can change. Okay, so so again, we can see it here in the blue boxes, 66 to 34, and then, oh yeah, now we're much higher because our second derivative was getting bigger. Okay, I hope that helps. If you do have questions though, please let me know. Otherwise, thanks for watching. I'll see you next time.